We are going to do an example reviewing our properties of exponents. And to do that, we are going to solve the equation 1 over 9 to the power of x equals 27 to the power of 2x times 81. Now, the strategy that we learned last week says we are going to find a common base. And once we have a common base, we're going to cancel. Now we have a few different options, 9, 27, and 81. Right now they're not the same number, so we have to ask, can we pick one of the bigger numbers and express it as a power of the smaller numbers? Well, the smallest number is 9. We know 9 squared is 81, but 27 is not a power of 9. So 9 cannot be our common base. The next question is there a number that we can express all three of these as a power of? If you've been thinking the number is 3, you would be correct. Because we can express 9 as 3 squared, 27 as 3 cubed, and 81 as 3 to the 4th power. So to get started solving this, we're going to make all of those substitutions. We have 1 over 3 squared to the power of x equals 3 cubed to the power of 2x times 3 to the power of 4. Now we might be tempted to just cancel all of our bases right now, but we're not ready to do that. First, we have to use our exponent properties. The first one is our power rule. When we have a power raised to a power, we multiply. So this becomes 1 over 3 to the power of 2 times x. Over here, we have 3 to the power of 3 times 2x, which becomes 6x, and it's all still multiplied by 3 to the 4th power. Now it looks like I'm running out of some space moving down, so I'm going to free up some space up here. The next power, or the next property that we're going to use is the quotient property. So if we move a factor from the denominator to the numerator, or in the other direction, we can do that by making the exponent negative. So to write this as 3, not 1/3, I have to make this negative 2x. The second property that we're going to use is our product property. So when we multiply two numbers that have the same base, we add their exponents. So we have 3 to the power of 6x plus 4. And now we have a common base, and this allows us to cancel. So I'm going to cancel these 3's and write my equation, negative 2x equals 6x plus 4. Now we've seen this type of equation before. It's linear. And so we can solve this equation like we would solve any linear equation. So let's add 2x to both sides. So that gives us 8x over here. And then let's subtract 4 on both sides. So we get negative 4 equals 8x. Now if we divide everything by 8, we have x is equal to negative 4 over 8. And if we reduce this fraction, we get negative 1/2. There we go. And that is our answer. So we have now reviewed all of our exponent properties, the product property, the power property, and the quotient property. And we have also reviewed how we can solve an exponential equation by finding a common base and then canceling that common base.